Hi folks, in this short video what I'm going to do is I'm going to show you how to do some of these card flipping problems in your problem sets. So remember with the card flipping problem, you've got a sequence of cards with some information on it. You've got one of the sides revealed to you, and you've got a conditional about those cards, and you've got to work out how many of those cards you need to turn over in order to rule it out that that conditional is false. So the first thing you need to understand with respect to these cases is that the entire thing is a way of thinking through what's going on with the conditional. So we need to come back to the conditional and think about how that works. So recall the basic conditional from propositional logic, the truth table that we've got for it. Looks like this, right? So we've got a basic truth table for the conditional. Now what we're trying to do is we're trying to rule it out that the conditional is false. There are two ways to rule it out that the conditional is false. The first way to rule it out that the conditional is false is to show that the antecedent, the thing on the left-hand side, is false. Because remember that the conditional is only false in one situation, when you've got the first thing and you don't have the second thing. So if you don't have the first thing, then you know that the conditional can't be false, right? So you can rule it out that the conditional is false by showing that you don't have the first thing, because you'll never get that situation where you've got the first thing and you don't have the second thing. The other way to rule it out that the conditional is false is to show that the consequent, the thing on the right-hand side of the conditional, is true. If you've got the second thing, then you're never going to get a situation in which you've got the first thing, but you don't have the second thing. So you'll have ruled out that falsifying case. Another way of seeing what's going on here is that when you show that the thing on the left is false, then you're sort of locked into these two rows in the truth table and you can't access this falsifying row, the second row. And similarly, when you show that the consequent is true, you're locked into the first and the third rows and you can't access that second row, you can't access that falsifying row in that case either. So when we're looking at these card problems, what we're trying to do when we're trying to rule it out that a conditional is false is we're trying to either show that the thing on the left is false, that the antecedent is false, or that the thing on the right is true, and we're trying to gather enough information to ensure that this falsifying case, this second row, isn't going to arise for those cards. All right, with that in mind, let's have a look at one of these basic card examples. So what I'm going to have is I'm just going to have three cards, just a very simple example to get us started. Now I've got a 5, a heart and a 6, and with respect to this set of cards I'm going to test the conditional. If a card has a 5 on one side, then it has a spade on the other side. Now, what I've got to try and work out is how many of these cards do I need to turn over in order to rule it out that the conditional is false. Now, remember, we're looking for the minimum number of cards that I could turn over in order to gain enough information to know that this conditional is not false, right? So I've got to try and work out what this minimum number is. Now what that means is I'm trying to look for the cards that I absolutely have to turn over, that I can't get away with not turning over in order to rule it out that this conditional is false, right? So is there any card such that if I were to leave it unflipped, it could potentially make this conditional false, right? If there is a card that is like that has that property, then I'm going to need to flip that card. Okay, so if I have a look at this, I'm going to go card by card. Look at this first card, I've got a 5. If this card has a spade on the other side, then that's going to falsify this conditional, right? If a card has a 5 on one side, then it has a spade on the other side. And remember, every card has a number on one side and a suit on the other side. So if I were to turn this card and it didn't have a spade on the other side, then that would falsify this conditional. So I'm going to need to check this card. So I know that I have to check this first one. The second card has a heart on it. If that card has a 5 on the other side, then that's going to falsify the conditional. So I'd better check this second card. If I don't check this second card, then I haven't ruled it out with respect to these three cards that the conditional is false. So I know that I have to check this second card. With respect to this third card, I don't have to check that one. And the reason I don't have to check that one is because there's no way for this third card to make this conditional false. If I turn this card over and it has a spade on the other side or a diamond or a heart, any suit whatsoever, no suit is going to make this conditional false. And that's because in this case, you don't have the first thing, right? So with respect to this third card, the antecedent of this conditional is actually false. And because the antecedent of this conditional is already false with respect to this card, this card can't falsify this conditional. These two cards can falsify this conditional. That's why we've got to check them. This third card can't falsify the conditional, so we don't need to check that. So the minimum num that we have to check here is 2 cards. We know that we had to check those first 2 cards because if we left them unchecked, then this conditional might still have been false. But we don't have to check this third card, and so the answer here is 2 cards in order to evaluate this conditional. All right, let's have a look at a slightly different example. All right, so let's just get rid of this. Let's have a look at another set of cards. I'm going to add another card. Let's have 4 cards now. So this time I've got 4 cards. And now I'm just going to put some random things on there. I've got a 7, I've got a 9, I've got a heart, and I've got a diamond. Now this time what I'm going to do is I'm going to check the conditional that if a card has a 7 on one side, then it has a diamond on the other side. Now, how many cards do I need to turn over in order to work out whether this conditional, in order to rule it out that this conditional is false with respect to these cards? So let's go card by card. Consider the first card. Can that first card falsify the conditional? Well, if I turn that card over and it's got a heart on the other side, then that would falsify the conditional. So in order to rule it out that the conditional is false, I'd better check this first card. With respect to this second card, notice that the thing on the left of this conditional, the first thing, is not present in this case. In other words, it's not the case that a card has a 7 on it, it has a 9 on it. So this is false here. And so I know that if I turn that card over, I'm not going to be able to falsify this conditional using that card, so I don't need to check that card. With respect to this third card, I've got a heart on one side. And if I turn that card over and it's got a 7 on the other side, then that would falsify the conditional. And so what I need to do is I need to check this card to ensure that it doesn't have a 7 on the other side in order to rule it out that the conditional is false. So I know I need to do at least that. So I've got to check this card here. Now with respect to this last card, this fourth card, that's got a diamond on one side. And so I know that it doesn't matter what the other side has on it, whether it's an 8 or a 12 or whatever, I'm not going to be able to falsify this conditional, because the only way to falsify this conditional is to have a 7 on one side and then something other than a diamond on the other side. Because I do have a diamond on the other side, I'm never going to get that case. In other words, the thing on the right of this conditional is true for this card. And because the thing on the right of this conditional is true for that card, I don't need to check it. It's not going to give me any information with respect to with respect to ruling it out that this conditional is false. So in this case, I only need to check 2 cards. Right. So what we can see here is we've got both of the sort of cases that happened for the truth table for the conditional turning up. We've got the thing on the left being absent for this second card, so we don't need to check that one. We've got the thing on the right being present for this fourth card, so we don't need to check that one. But for the first and third cards, we need to see what's on the other side of those cards before we can successfully rule it out that this conditional is false with respect to these cards. Okay, so far I've just been checking looking at how many cards I need to turn over in order to rule it out that the conditional is false. I haven't really been focusing that much on this concept of the minimum. What I'm going to do now is I'm going to look at a harder case where this concept of the minimum really comes into play, and we're going to see how to evaluate that sort of case. Okay, so let's have 5 cards this time. I'm just going to, again, put some random stuff on these cards. I'm going to put a 10. I'm going to put a diamond. I'm going to put a heart. I'm going to put a 3, and I'm going to put club. And now we've got to work out a conditional. Now this time what I'm going to do is I'm going to look at something a little bit more complicated. So far, the conditionals that I've given you have just been sort of going from a number to a suit, or you could have it going from a suit to a number, just from one thing to another. It's like just checking one side of the card to see what's on there in order to rule out the conditional's false. What I'm going to do now is I'm going to introduce a chained conditional, right? So two sets of conditions or two sets of conditionals that we're going to evaluate with respect to this particular case. And when we look at this, we'll start to see how this concept of the minimum really comes into play. Okay, so the conditional I'm going to look at is this. If a card has a 10 on one side, then if the card to the right has a diamond, so if the right card has a diamond, okay, then the card to the left of that card, actually no, I won't do that. I go, if a card has a 10 on one side, then if a card to the right of that side has a diamond, then the original card has a heart on the other side. All right, so we've got to try and work out how many we've got to turn over in order to work out whether this conditional is false. So if a card has a 10 on one side, then if the card to the right of that card has a diamond on the other side, then the original card has a heart on the other side. All right, so let's start with the easy case. Let's start with this 10. So if we look at the card, we've got a 10 on this side, and the card to the right of it has a diamond on the other side. Given that this condition is met and this condition is met, we've got to check that final condition in order to work out whether or not this conditional is, in order to rule it out, this conditional is false. If I didn't turn this 10, I'd have done something wrong because I would have left out a case that could potentially have falsified the conditional. So I know I've got to check this. All right, let's have a look at some of these other cases. For this second case, I've got a diamond on one side, right? Now, to the right of that card, so I don't know whether I've got a 10 here, so I don't know whether this first part of this conditional is true or not. What I do know is that the card to the right of that card doesn't have a diamond, so this part of this conditional here is false. And because this part of this conditional here is false, I know that this conditional here, well, doesn't matter what's going on the right-hand side, I know that this conditional here is true because of the truth conditions for the conditional. And because I know that that conditional is true, I know that this original conditional is true with respect to this card. In other words, this card here and the sort of card surrounding it, I don't need to turn this card over to check to see whether it's got a 10 on the other side because the card to the right of it doesn't have a diamond. And because the card to the right of it doesn't have a diamond, there's no way that this card here can falsify the conditional. So I don't need to check that card in this particular case. All right, so let's have a look at this next situation. This next situation is going to be much more complicated, and this is where things are going to get a little bit sticky. So with this next one, I don't know, so I'll just get rid of these F's and T's just so we got a clean slate to start with. So with this third card, I don't know whether it's got a 10 on the other side, okay? I know that it's got a heart on this side. Actually, sorry, this case should be okay. So I don't know whether it's got a 10 on the other side. I do know, however, that it's got a heart on this side, right? So what I know is that this part of the conditional, this part here, namely that if a card has a 10 on one side, then the other side of it has got a heart on it, if the card to the right of that is a diamond, is actually true, right? So this card has a heart on it, so there's no way that I could get a case where I've got something that falsifies this conditional, because I'm not going to get a case where I have a 10 on one side and something other than a heart on the other side, because I've got a heart on this side. In other words, this part of this conditional here is true, and because this part of this conditional here is true, we know that that conditional's got to be true, and because this whole conditional is true, we know that that conditional's got to be true, and so we know we don't need to turn this card because that card is not going to falsify the conditional. It's not going to give us any information that's going to falsify this conditional here. So we don't need to check what's going on with that third card either. All right, so far so good. What about card number 4? Well, card number 4 doesn't have a 10 on one side, right? So we know that this antecedent of this conditional here is false for that card. So it doesn't matter what's going on with the stuff to the right of that card. This conditional is true, and so we don't need to check that card in order to rule it out that this conditional is false. That card is not going to be able to falsify this conditional for us. This leaves us with the final card. I don't know whether or not it's got a 10 on the other side, but it doesn't matter because there is no card to the right of that card. Because there is no card to the right of that card, it's false that the card to the right of that card has a diamond on one side because there is no such card. And because that's false, I know that this conditional here is true, which is going to make, again, this conditional true, so I don't need to check this card either. So all up in this situation, I only need to check one card. I only need to check one card because the only card that could possibly falsify this conditional is that first card. So I've got to make sure I check to see what's on the other side of that card in order to rule it out that the conditional is false in this case, right? And I know that no matter what else I do, I've got to check at least that card. Now, something that's important to notice here is that it's perfectly open to me to check more than one card, right? So I could have checked all of these cards, right? And I could have checked all of these cards, and in checking all of them, I would have successfully ruled it out that the conditional is false. But I only needed to check one card. So there's a sort of maximally efficient thing I could do and a maximally inefficient thing I could do. The maximally efficient thing I can do is to just check this first card. The inefficient thing I can do is to check all of the cards. Okay? And so when we're sort of like this, when we're thinking about the fewest number of cards that I need to check, in this case, the fewest number of cards I need to check is one card. Of course, I could check more, but I don't need to. I just need to check this one. All right. I want to do one more case in order to sort of get this. So I've just sort of introduced this notion of a minimum and a maximum. We've sort of seen that there's a minimally, like a most efficient and a least efficient thing I can do, and they're sort of lining up with notions of minimum and maximum. What we want to do is we want to try and get a little bit clearer on this notion of a minimum by looking at one more case. So I'm just going to get rid of some of this. I'm going to keep the same conditional, just because it's going to be easier for us, I think. And I want to, actually no, I'll do a different conditional, because I think that ultimately it might be a little bit confusing if I do the same conditional. So let's do a completely new case. So in this case, I'm going to go 10, 5, diamond. Club, three, and we're going to look at another one of these nested conditionals. So this nested conditional is going to be if a card has a 10 on one side, then if the card to the right of that card has a heart, then the original card has a diamond on the other side. So this is sort of similar to the case we were just looking at, okay? So if a card has a 10 on one side, then if the card to the right of that card has a heart on the other side, on one side, then the original card has a diamond on the other side, okay? Now we're going to go, just as we have in the last few cases, we're going to go card by card. And we're going to try and work out how many cards we need to flip. All right, so let's start with the obvious case, this first card. We've got this first card and it's got a 10 on one side. So we know that this first part of the conditional is true. And so this first card looks like it has the potential to falsify this conditional because if the other side of the card doesn't have a diamond on the other side, a diamond on that side, then it might turn out this conditional is false. All right, so first card, we've got a 10 on one side. Now we look at the card to the right of that card. We don't know whether the card to the right of that card has a heart on the other side or not, right? We don't have that information. So I'm just going to put a question mark here with respect to this. And then we don't know whether the original card has a diamond on the other side. So what we're going to try to work out is how many cards here do we need to turn over in order to rule it out that this conditional here is false, right? And what we're doing here is we're looking for this minimum number. All right. Now, what I want to do is first of all find let's just think of a case that would rule it out that the conditional is false. So suppose that I turn this second card, right? I turn this second card and it's got a diamond on the other side. Okay, let's suppose I just turn that second card and it's got a diamond on the other side. If I turn that second card and it's got a diamond on the other side, then this part of the conditional is false, which makes this conditional true, and which makes this whole conditional true. Right, so if I were to turn this second card and it had a diamond, then I will have ruled it out that the conditional is false. Okay, so I know that there is some way, there's a possible way to turn one card and to work it out and to rule it out that the conditional is false. Okay, suppose, however, that I turn this card and it's got a heart on the other side. If I turn the card and it's got a heart on the other side, then I'm going to have to check this first card. Because if I turn the card and it's got a heart on the other side, then this first card is now capable of falsifying this conditional. Because if it's got a heart, then this bit here is true, this bit here is true, and so we need to see if it's got a diamond. Okay? So far what I've given you are sort of two things that could happen, depending on what occurs when I flip this card. In one case, so I'm going to just put these up as two possibilities. So we've got a sort of bifurcation between two possibilities. In one possibility, I get a diamond, and I flip one card in order to rule it out that the conditional is false. In the second possibility, I get a heart, and I end up flipping two cards, right? So in that second possibility, I end up flipping a second card. Now, what we've got to try and work out is what's the answer here, right? So I know that I've got to flip something, but how much do I need to flip? Okay? Now this is where we get this concept of the minimum coming sharply into view, right? I'm looking for the minimum number. And what that means is that when I look at all of the possibilities, all of the ways of flipping the cards to rule it out that the conditional is false, I'm looking for the fewest cards that I can get away with flipping in order to successfully rule it out that the conditional is false. What's the number that I know that I'm going to have to flip at least that many in order to get the relevant information? And if I look at these two possibilities, I know that I have to flip at least one card. The second possibility, I have to flip at least one card. And in the first possibility, I have to flip at least one card. And indeed, I know that no matter what I do, no matter what possibility, no matter what information this card gives me, I have to flip at least one card, right? And that's the relevant concept of the minimum that we're looking for. We're looking for what I have to do come what may. Whatever possibility arises, how many cards do I end up having to flip? And in this situation, The number of cards that I know that I'm going to have to flip no matter what is 1 card. Right? And that's the relevant minimum that we're looking for. Okay? So it's very important to see that we're not looking for this second thing here. We're not looking for the sort of number of cards in the worst case scenario where you flip this and you get a heart that I have to turn over in order to rule it out that the conditional is false. Instead, if we think of it in terms of best and worst case scenarios, I'm actually looking for the number of cards that I flip in the best case scenario, right? The case where I flip cards and I successfully rule it out that the conditional is false using the fewest number of flips I possibly can. Okay, so when we're looking for the minimum in these cases, we're looking for the fewest number of flips that I can get away with making, which corresponds very roughly to the best case scenario, the case where I turn the fewest number of cards to get as much information as I need in order to rule it out that the conditional is false. All right, and so the definition of minimum that's given in the problem sets reflects this. The minimum is defined in the following way. The minimum number is the number such that in every possibility in which I successfully rule it out that the conditional is false, I flip at least that many cards. So here we've got 2 possibilities in which I successfully rule it out that the conditional is false. In one possibility I flip 2, the other possibility I flip 1, and so in every possibility I flip at least 1 card, and so that's the minimum. That's the number that we're looking for. Okay, so with respect to this first card, we're still just working on the first card for this problem. With respect to this first card, how many cards do I need to flip in order to work out the minimum? Well, with respect to this first card, I only need to flip 1 card, right? That's the minimum number. That's the number that I know that I'm going to have to flip at least that many, come what may, and I'm going to have to flip this second card in order to get that information. So I'm just going to put a tick here to say that I had to flip something, and in this case and I'm going to put a 1 to give you the information that I'm flipping just 1 card for that case. Now, let's move on to the second case. With respect to this 5, do I need to flip anything? Well, notice that 5 is not a 10, and so the first part of this conditional is false for that second card, and so I know that I'm never going to get a falsifying situation, so I don't need to flip anything in order to rule it out the conditional is false with respect to that card, because that card can never falsify the conditional, so I don't need to flip that card. This brings us to the third card. I don't know if I've got a 10 on the other side of that card. What I do know is that the card to the right of it doesn't have a heart. And because the card to the right of it doesn't have a heart, this part of the conditional here is false, which makes this second conditional true, which makes this first conditional true, and so this third card can never falsify the conditional. What about the fourth card? The fourth card, I don't know if it's got a 10 on the other side. I also don't know if the card to the right of it has a heart on the other side. But what I do know is that the first card does not have a diamond on the other side, right? So I know that there's no diamond here. So what I need to do is I need to check to see potentially whether there's a 10 on the other side, depending on whether this is a heart or not. So this pair of cards here, structurally, is reflecting what's going on with the first pair of cards. So I'm going to have to perform a similar kind of reasoning. So let's go through the possibilities. Suppose that I flip this first card and it's got a diamond. Flip the last card and it's got a diamond. Then I know that the left-hand part of this second conditional here is false, which makes the second conditional true, which makes the entire thing true. So I know that if I flip that card and I get a diamond, then the entire conditional is going to be true. So in one flip, I can rule it out that the conditional is false for one possibility. So there is a possible way to flip just one card and rule it out that the conditional is false. Suppose, however, that I flip this card and I get a heart. If I flip this card and get a heart, then then this part of the conditional is true. And I know that this part of the conditional is false. And so I need to check this card in order to see whether it's got a 10 on the other side. So I would have to flip both of those cards in that possibility, right? So I've got two possibilities, just like I had with the first case. And in this possibility, I've got one possibility, with these two cards, I've got one possibility where I flip two cards, and I've got one possibility where I flip just one card. Again, what are we looking for? We're looking for the minimum. What's the fewest number of cards that I can get away with flipping in order to rule it out that the conditional is false? Where that corresponds to the possibility with the fewest number of flips, or the best case scenario. What's the best case scenario here? The best case scenario is that I get a diamond, or something that's not a heart, and that falsifies this second part of the conditional, which makes the entire conditional true. So in the best case scenario, I flip just one card. In the worst case scenario, I flip two cards. We're looking for the best case scenario, so I'm just going to flip one card here. With respect to this last card, do I need to flip anything? Well, it doesn't have a 10 on it, so the antecedent here is false. Also, there's no card to the right of it, so this part of the conditional here is false for the same reason as it was in the previous case that we looked at, and so I don't need to flip anything here. So how many cards do I need to flip? Well, the minimum number of cards is 2 cards. That's the minimum number of cards that you can get away with flipping to rule it out that the conditional is false. What would it take if things go really bad to rule it out that the conditional is false? Well, you would need to flip the first 2 and the last 2 in the sort of worst case scenario. So there is a kind of maximum number of cards that you would need to flip to rule it out that the conditional is false, and the maximum number of cards to rule it out is 4. We're looking for the minimum, right? So now we've got the 2 concepts of minimum and maximum in view. The minimum is the fewest number of cards that you need to flip that you cannot get away with not flipping in order to rule it out that the conditional is false. The maximum is the most number of cards that you would end up flipping in order to rule it out that the conditional is false in sort of the worst case scenario, the most that you would need to flip. We're looking for the fewest that you need to flip, the minimum, so we're looking for just these 2 cards. We're flipping the second and last, but for those 2 cards we just have 1 flip each, which means that the minimum in this case is 2 cards. Okay, so that's how to do these card flipping questions. As you can see, the cases get really hard when you're starting to deal with these nested conditionals and you're looking for this concept of the minimum. So long as you keep in mind that what you're sort of algorithmically searching for is the best case scenario, then that's going to lead you towards the sort of most efficient way of flipping in order to rule it out that the conditional is false. Interesting to think about what these notions of best case and worst case scenario are really doing. When you're sort of doing everyday reasoning and thinking through cases, often what we're doing is we're looking for optimal ways to solve a problem. We're looking for optimal solutions, and these minimum and maximum notions are really corresponding to certain notions of optimal reasoning that can happen when you're trying to work something out when you've got a kind of impoverished amount of information. And this has lots of real-world applications. There are lots of times when you need to work something out, and you need to do it in the most efficient way you can by gathering the least amount of information that you need to. And this sort of thinking through these sorts of cases can give you a sense of exactly what that kind of least amount of information would ultimately amount to. All right, thanks for listening. Good luck with these problems in your problem sets.